Alright, so lesson 33, we're going to talk about dividing polynomials. So this division algorithm, it looks scary, it's really not. All it's saying is that you can take a polynomial, divide it by another polynomial, get another polynomial plus a remainder. Okay, so it's really just saying you can divide polynomials, but you may get a remainder. Alright, so we have long division, we have synthetic division. Long division has its place because synthetic division only works when you're dividing by something that's linear. So to do long division, you have to remember that you know how to do regular division. So I'm going to spare you the third grade long division tutorial. Hopefully you remember how to divide. So the first number goes under the house. And you have to have all of your place values. So since we start with x to the fourth, we have to have an x to the third. We have to have an x squared. So since there isn't one up there, there's none. We have to have a regular x and we have to have a constant. All right, the second number goes outside. If you're missing things in between terms, you got to fill them in. If you're missing on the end, it's not that important. Okay, so in order to do this, hold on, let me see if I can move that over. I'm going to show scratch work, so I'll move this over here out of the way. Okay, so here we go. I don't need to see the stuff that I'm writing over here to the side. I don't need to see your scratch work. I understand that you can do that in your head. I'm just trying to make sure you understand where the information I'm writing down comes from. Okay, so it's 3 steps, and you repeat them until you can't repeat them anymore. So step 1, take the first thing underneath, divide by the first thing outside. That goes up top. Then you're going to take that thing you just got, multiply by the jump on the outside. Write it down underneath. The goal here is to subtract, and this first term cancel. So if those don't match, you've got a problem. Alright, so remember that you're going to go through and subtract, which means that minus becomes a plus. So we have 7x to the third, and bring all of these down. Alright, that's round 1 of your 3 steps. Now you just repeat. So first thing underneath, divided by first thing outside. Write it up top. Multiply that by the thing on the outside. Write that underneath. Go through and subtract. Bring down the extras. Alright, repeat. So first thing underneath, divided by first thing outside. Write that down up top. Multiply by what you're dividing by. Oh, I just divided by 2 when I shouldn't have. This should clearly be a 14. Sorry if I just thoroughly confused you. Okay, back up to here. This is clearly 14. Alright, so writing that here. Okay, so now we're going to go through and subtract. so you notice that this x has a smaller degree than this x. That's when you know you're done. So our answer is going to be what we got up top plus the remainder over what we were dividing by. And if I can move that down because it's a little in the way. No, this one is all of it. Alright, I'm going to erase this and move it down. That way when I make a copy of this, it'll not all run together. Alright, so our final answer, 2x squared plus 7x plus 14 plus 21x minus 10 over x squared minus 2x. Okay. Alright, so another example of long division. You can pause and try it if you want to make sure you know what you are doing. Alright, this one we're not missing any terms, so no zeros need to be filled in. Alright, so if we take 6x to the third, divide by 3x, we're going to get 2x squared. If we multiply that back with what we're dividing by, we're going to get 6x to the third minus 2x squared. Remember that we need to subtract. That is clearly an addition. So that is 9, not 5. Alright, so repeat our steps. So 9x squared divided by 3x is 3x. 3x times 3x minus 1 is 9x squared minus 3x. Go through and subtract. Alright, repeat. So 15x divided by 3x is 5. 5 times 3x minus 1 is 15x minus 5. So I need a 5 up here. I need my 15x minus 5 here. We're going to go through and subtract. And then find a color. So those cancel, you have no remainder. So your final answer is just 2x squared plus 3x plus 5. Alright, so that division algorithm, you would, in case you care, we're saying that this is equal to this times this. I can't see me point with my fingers, can you? This is equal to this times this plus 0, because that's what the remainder is. Alright, so next we should have a synthetic division. So synthetic division, again, the reason that we have to know how to do long is synthetic only works if you're dividing by a linear, and it's only fun, since y'all don't like fractions, if you're dividing by a linear that looks like this. If there's a coefficient on that x, then you're going to have fractions, and y'all don't like those. Okay, so synthetic division is like backwards division. You never actually divide, you just multiply and add, but it gets the same result. So you're going to do an upside down division house that takes like 2 lines of your paper. You're going to put the coefficients of the first line, filling in zeros for anything that's missing. So since there's no x squared, we put 0 where x squared should fall. The last number you get down here is the remainder, so I put it in its own little box. the number that goes out here is always the opposite of this guy, so -2. Alright, first number always falls straight down. And then it's multiply, write it down, add that column. Multiply, write it down, add that column. Multiply, write it down, add that column. Alright, so you took something to the third, divided it by something to the first, so you're going to end up with something to the second. So you get 1x squared minus 2x minus 3, and the remainder 0, so you don't have a fraction on the end. Alright, so another example. We're going to put 3 on the outside, because that's the opposite of this guy. Our coefficients are 6, there's nothing to the fourth, so 0, -2, 4, -3, 1. That last number is going to be your remainder. Alright, so 6 falls down. 6 times 3 is 18. 18 times 3 is 54. And 52 times 3 is 156. And 160 times 3 is 480. Yeah, that's right. So what's that, 477? So 477 times 3 is 1431. I'm checking my work because those numbers seem crazy. I agree with myself. Oh, except for that last number because I'm dumb. That's clearly 2. Okay, so we started out to the 5th, so we're going to be to the 4th. So it's going to be 6x to the 4th, plus 18x to the 3rd, plus 52x squared, plus 160x, plus 477, and then plus 1432 over what we were dividing by. Alright. So that is synthetic division. We're going to use it a lot over the next couple of days for several things. The first of those is using the remainder theorem. Alright, so the remainder theorem used to be like a big thing because calculators weren't a thing. And you could plug numbers into a function and figure out the answer using synthetic division, which was a little simpler than actually doing all of the work. So, looking at what's here. If we're told to use the remainder theorem to evaluate a function at a given value, you're just going to do synthetic division. They gave you a value, not a factor, so you don't change the sign. If they give you a number, you use that number. If they give you a factor, like an x plus 2, then you would change the sign. Alright, so we do our synthetic division, and we get -9 as a remainder. So what the remainder theorem says is that if you do synthetic division with that number that you're trying to plug in, the remainder is the answer. So you have figured out that f of -2 is -9. If you want to check that, you can. You don't have to. But there's proof. All right, so that's the remainder theorem. Do synthetic division, remainder is the answer. All right, and the factor theorem is saying that if you divide and get a remainder of 0, then the thing you were dividing by is a factor. It goes in evenly. There's no leftovers, so that makes some sense. So an example of how they're going to use that is they may just ask you to show that two things are factors and then find the remaining factor. So that just means do synthetic division and then factor what you get. So testing out this first one. So if x minus 2 is a factor, that means we can do synthetic division with a 2. We get this. We got a remainder of 0, so we know that it's a factor. Check. All right, so then we're checking, is x plus 3 a factor? Well, we put negative 3. Do synthetic division. We get a remainder of 0, so check, that's a factor. Now notice when we went from here to here, instead of going back to the original problem's coefficients, we used this guy. So the same concept as if I told you to do 48 divided by 3 and then divided by 4. You would divide by 3, get an answer, and then divide by 4, that new answer, not 48. So when you divide off a factor, use the answer as you keep going. That way you whittle the problem down smaller and smaller. All right, so when you get done checking your second factor, you have a quadratic. As much as we don't like solving quadratics, those are the easiest thing to solve. So with polynomials, we try to whittle them down to a quadratic. Once you have a quadratic, then hopefully it'll solve by factoring. If not, then you have to use other methods like the quadratic formula. But for today, I'm just going to ask you to factor, so you're going to get a quadratic that will factor. So if you take this quadratic and you factor, then the fully factored form of the original problem are the 2 factors they gave you, and then the 2 factors that you found. All right, so they want us to kind of use that factor theorem to help us solve an equation. They give us one root to work with. All right, so we know that negative 1 is a solution. If it's a solution, that means that x plus 1 is a factor. We're going to put in our coefficients. I made my line too long. We're going to do synthetic division. We should get a remainder of 0. I'm not going to talk you through synthetic division. I did that already. Alright, so we did our synthetic division. So we now have 15x squared minus x minus 2. Alright, so to get solutions of a quadratic, you're just going to factor. So I'm thinking maybe a 3 and a 5. And if I put a 2 here, that'll give me 6 and 5, which will give me negative 1. If this is negative, then that's positive. So if we say that this equals 0, we get negative 1/3. And if we say that this equals 0, we get 2/5. So if I'm solving, don't forget that they told you negative 1 was a solution. So the 3 solutions to that polynomial are negative 1, negative 1/3, and 2/5. All right, I believe that's it. Yes, all right, so here's your assignment. Again, as always, let me know if you have questions. Please email me. I'll be happy to talk back and forth with you, help you figure out anything you're not understanding.